Okay, this is a conservation of momentum inelastic collision problem. The problem assigned reads, a 30-gram bullet is fired into a stationary 1 kilogram block of wood, which is initially at rest on a frictionless surface. The bullet is fired at 280 meters per second. The bullet becomes lodged into the wood, and then, so it says that the collision can be considered inelastic. And then it says determine the final speed of the bullet and the block after the impact. So I've made a sketch ahead of time. You can see that I've described the bullet as object number 1. It's initially moving in at this known speed, v1. So we know that v1 is initially 280 meters per second. That's given to us right in the problem, so we can kind of tease that out right here. And they also tell us that the 1 kilogram block of wood is initially at rest. So therefore, we know that V2 is equal to 0. So there's some kind of initial information that we know. We also know the mass of block number 1. It's given to us in grams. So we're going to have to make a conversion. That should set off some flags. 30 grams when converted to kilograms is 0.03 kilograms. And the mass of block 2 is already given to us in kilograms. It's 1. So when you solve a problem like this, I highly encourage you to start by stating your conservation of momentum principle. So this is the Greek character sigma that I've written that looks like the funky E. And the Greek character sigma means add up all the pieces together, add everything together. So sigma momentum, we're going to use the capital letter P to describe momentum. The sum of the total momenta in the system before the collision must be equal to the sum of all the different individual momenta in the system after the collision. So we've characterized the system, or we've described it as objects 1 and 2. So now I can say that the momentum of object 1 plus the momentum of object 2, that's before the collision, is equal to the momentum of object 1 plus the momentum of object 2 after the collision. This problem, the next step would be basically to express each one of these terms, specifically the momentum term, separate it into its parts, right? So momentum is mass times velocity. So the momentum of the bullet, in this case, would be m1 v1. And I'm going to do the same thing for all of these terms, kind of split them up into their parts. So the momentum of object 2 would be m2 v2, and on the right-hand side, I could say that the momentum of the bullet after the collision is going to be m1 v1 prime plus m2 v2 prime. By the way, that prime denotes after the collision. So a couple of things we need to do here. First of all, we know that the velocity of the block before the collision was 0, so that whole term is going to go away because anything multiplied by 0 is 0. And then also for an inelastic collision, we're going to basically say that v1 prime has to be equal to v2 prime because they're stuck together, right? So the bullet here and the block here are both moving together after the collision, so they have to have the same velocity. So rather than use two separate terms, v1 and v2 prime, we're just going to call that VF. So I'm going to basically replace each instance of V1 prime or V2 prime with VF. And then I get something that looks like this. So on the right-hand side, I get M1 VF plus M2 VF. And on the left-hand side, I get M1 V1. Well, I'm solving for VF, so I'm going to factor it out. And when I factor out a VF inside the parentheses, I get a binomial, M1 plus M2, and on the left-hand side I got M1 V1. Now I'm going to divide both sides by M1 plus M2, which is the total mass in the system, M1 plus M2. This cancels out, and I now have kind of the expression that I'm looking for. VF is equal to M1 V1 over M1 plus M2. Now I'm ready to basically substitute my numbers in, so I'll kind of finish my last step here. VF is equal to the mass of 1, which is 0.03 kilograms, the mass of the bullet, times its initial velocity, which is 280 meters per second. And then I'm going to divide that by the total mass in the system, 0.03 kilograms plus 1 kilogram, which is just 1.03 kilograms. When I run that through my calculator, I get about 8.155 meters per second. If I'm dealing with sig figs, or if I just wanted to truncate that to fewer digits, I would call that 8.2 meters per second. And that would be the solution to kind of an introductory inelastic collisions problem.